So guys, in today's session we are going to see certain important compounds of your oxygen. So to begin with, the first important compound we are going to see is your dioxygen molecule, or in simple words we can say as your oxygen molecules, that is your O2. So first of all, we'll see that how in lab one can easily prepare your dioxygen. Of course, there are mainly three methods, the laboratory preparation, where you can easily prepare your oxygen in the lab. So first of all, the first preparation which we are going to see is by the heating of oxygen containing salts. Heating of oxygen containing salts. Now the oxygen containing salts and the header, basically we can see it could be your chlorates, even it could be your nitrates, and also your permanganates. So these are some of the oxygen permanganates. Oxygen containing salts. That is, for example, if I choose a reaction as chlorate salts, I can use that as potassium chlorate, which on heating in the presence of your manganese dioxide, you could just see that we would be getting your KCl plus along with that one oxygen gas getting liberated. So when you just balance this, you will be getting as 2 KClO3, 2 KCl, so 3O2. So one such preparation we have saw that how can you prepare the oxygen in the lab by heating the oxygen containing salts, that is your chlorates, nitrates and permanganates. Coming to the second preparation, we can just see that it is by the thermal decomposition of oxides of metals. Thermal decomposition of oxides of metals. Okay, thermal decomposition. Oxides of metals means, for example, Ag2O, oxide of a metal. So just by heating, it will going to decompose to give you as 4Ag plus that of your O2. So of course now here it should come as 2Ag2O. That is the reason we'll be getting as your 4Ag. Of course here Ag will be solid, O2 will be a gas. Whereas Ag2O, once again, it is a solid. Coming with respect to mercuric oxide, HgO, here also you could just see thermal decomposition, which gives you as a Hg plus O2. But do remember this Hg is in a liquid state, whereas obtained oxygen will be in the gaseous state. Similar is the case with respect to the lead oxide, PbO2, which is a solid, which is going to give you as PbO. But do remember, along with that one, O2 gas getting liberated. So what is the process we have done over here? Just by the thermal decomposition of your oxides of the metal, you can easily get your oxygen as a product. The another important and the easiest process is by the decomposition of your hydrogen peroxide. So whenever you're going to decompose your hydrogen peroxide in the presence of any catalyst, okay, metal catalyst, finely divided metals, or even that of your manganese dioxide, basically your hydrogen peroxide will decompose to give water, and along with that of your O2 gas. That is the reason we say as your H2O2, hydrogen peroxide, is a good oxidizing agent, because it has the capacity to give the oxygen. You can just see in this reaction, even by the decomposition of your hydrogen peroxide also we are able to obtain your oxygen. So these were the three methods in which you can easily prepare your dioxygen in the lab. Coming with respect to the large scale production, okay, for example in industries, in case if you want your oxygen, so of course we know that whenever we talk about industries, we require very sophisticated methods, and also the money investment should be very less. So on a large scale preparation, what actually we do is, it is by the electrolysis of your water. Electrolysis of water, easily one can manufacture your oxygen gas. So when you electrolyze your water at the cathode, what happens? Hydrogen is getting released. At the cathode, hydrogen gas get releases, and at the anode, or whatever your oxygen part is there, that gets released. So large scale yavattu ನೀವು dioxygen prepare ಮಾಡಬೇಕು ಅಂದ್ರೆ, it is by the electrolysis of water. Water is a very, what you can say, easily available material and the cheapest material. Okay, so that is the reason it could be used easily by the industries. So aduna ಏನು ಮಾಡ್ತಾರೆ, when they do as electrolysis, of course electrolysis ಅಂದ್ಕೊಳ್ಳಿ electrodes ಇದ್ದೇ ಇರುತ್ತೆ, electrode reactions ಆಗುತ್ತೆ. ಸೊ ವಾಟರ್ ನ ಎಲೆಕ್ಟ್ರೋಲಿಸಿಸ್ ಮಾಡ್ತಿದ್ದೀರಾ ಅಂದಾಗ ಕ್ಯಾಥೋಡ್ ಹತ್ರ ಏನ್ ಬರುತ್ತೆ? ಹೈಡ್ರೋಜನ್ ಬರುತ್ತೆ, ಆನೋಡ್ ಹತ್ರ ಆಕ್ಸಿಜನ್. Okay, Not only this, even you can easily by the atmosphere, even the atmosphere has gifted us the oxygen. ಅಲ್ಲೂ ಕೂಡ ನಾವೇನ್ ಮಾಡಬಹುದು, ನಿಮ್ಮ ಅಟ್ಮಾಸ್ಫಿಯರ್ ಏನ್ ಗ್ಯಾಸಸ್ ಇರುತ್ತೆ ಅದನ್ನ ಲಿಕ್ವಿಫೈ ಮಾಡ್ತೀವಿ. ಲಿಕ್ವಿಫೈ ಮಾಡೋಕ್ಕಿಂತ ಮೊದಲು ವಾಟ್ ವಿಲ್ ಡೂ, ವಿಲ್ ಬಿ ಟ್ರೈಂಗ್ ಟು ರಿಮೂವ್ ಯೋರ್ CO2 ಅಂಡ್ ವಾಟರ್ ವೇಪರ್. ಫಸ್ಟ್ ಇವೆಲ್ಲ ನಾವು ಇಂಪ್ಯೂರಿಟೀಸ್ ನ ಆ ಒಂದು ಅಟ್ಮಾಸ್ಫಿಯರ್ ಏರಿನ ತೆಗೆದು ಹಾಕ್ತೀವಿ. ದೆನ್ ವಿಲ್ ಬಿ ಅಂಡರ್ಗೋಯಿಂಗ್ ಇಟ್ ಆಸ್ ಅ ಫ್ರಾಕ್ಷನರಿ ಡಿಸ್ಟಿಲೇಷನ್. ಲಾಸ್ಟ್ ಗೆ ನಿಮ್ಗೆ ಡೈ ನೈಟ್ರೋಜನ್ ಮತ್ತೆ ಡೈಆಕ್ಸಿಜನ್ ಸಿಗುತ್ತೆ. So these were the certain important process, or we can say some important preparation when one can easily prepare your dioxygen both in the laboratory and that of your, what you can say, commercial purpose. Coming with respect to the properties, okay, dioxygen properties ನೋಡ್ತಾ ಬರೋಣ. What are the main properties? How can you get to know that whatever the gas you have been obtained in the above process, whether it's a dioxygen or yes or no? So basically, whenever we talk about its appearance, remember your dioxygen is a colorless, alva. Of course, atmosphere alli dioxygen untu ನಾವು ನೋಡಕ ಆಗೋದಿಲ್ಲ, which you can easily understandable that it is a colorless, and of course it is not having any smell, so therefore it is also an odorless gas. Odorless gas. So when we talk about the first appearance of your dioxygen, basically it is a colorless and an odorless gas. Coming with respect to its isotopes, what are the major isotopes of oxygen? Andre, there are mainly 3 isotopes one can observe from oxygen, that is your O16, O17 and that of your O18, where you can just see that the mass number is changing but the atomic number remains the same. That is the reason we call it as an isotopes. So when we talk about the isotopes of oxygen, mainly 3 isotopes of oxygen which are very stable. They are O16, O17 and O18. Most important property which I would like to quote over here is, remember your molecular oxygen, that is your O2, is paramagnetic in nature. Is paramagnetic in nature, though it is having an even number of electrons. Though it is having even number of electrons. So what do you mean by paramagnetic? The one which will be attracted by the magnetic field, alva. So aduna navenanta heltivi paramagnetic. So yaudadu, whenever you talk about your dioxygen, do remember it is paramagnetic in nature. But what is a point we have to note over here? Though it is having an even number of electrons, your oxygen molecule acts as a paramagnetic. Coming with respect to its bond dissociation enthalpy. Bond dissociation enthalpy. Do remember the dioxygen's bond and dissociation enthalpy is very high. Very high. The reason is why? Because whatever the bond which is existing between the oxygen is a double bond character, and in order to break that bond, what happens, nearly an enormous amount of energy has to be supplied, nearly in the range of 493 kilojoules per mole. 493 kilojoules per mole. That is the reason we say that the bond dissociation enthalpy of oxygen double bond is very high. Coming with respect to its characteristic reactions, basically your dioxygen reacts with all the metals. ಏನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ ನಾನು, ಡೈಆಕ್ಸಿಜನ್ ಏನಿರುತ್ತಲ್ವಾ ಅದು ಆಲ್ಮೋಸ್ಟ್ ಎಲ್ಲಾ ಮೆಟಲ್ಸ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. ಬಟ್ ದೇರ್ ಆರ್ ಸರ್ಟನ್ ಮೆಟಲ್ಸ್, ದಟ್ ಈಸ್ ಯೋರ್ ಪ್ಲಾಟಿನಮ್ ಅಂಡ್ ಗೋಲ್ಡ್, ವೇರ್ ಯೋರ್ ಆಕ್ಸಿಜನ್ ಡಸಂಟ್ ಗೆಟ್ಸ್ ರಿಯಾಕ್ಟೆಡ್. And even with some of the noble gases also, your, what you can say, dioxygen doesn't react. Coming with respect to certain important reactions, so when you take with respect to the calcium, as I said, your oxygen reacts with almost all metals. The reaction goes in this way. Ca plus O2 gives you CaO. In order to balance this, 2CaO and 2Ca. Similarly, coming with respect to the aluminium, when it reacts with oxygen, it gives you as aluminium oxide, it is Al2O3. So in order to balance this, I should write over here what? 2Al2, so here 4Al, 2 3s are 6, so 3O2. Similarly, P4 plus 5O2, when you take P4 plus 5O2 gives you P4O10. Yes. Similarly, C plus O2 gives you CO2. It is with certain non-metals, carbon jothe react agta untu. Okay, these are the reactions which include with respect to the metals and non-metals. Okay. Coming with respect to the zinc sulfide also, zinc sulfide plus 3O2 gives you as zinc oxide plus SO2. So these are some of the important reactions. Okay, one has to remember that how does your oxygen, that is your more particularly dioxygen, reacting with metals. So whenever it is going to react with metals, they are going to form a respective metal oxides. Alva, you just see calcium has been converted to calcium oxide, aluminium to aluminium oxide. zinc to zinc oxide. Okay, so ಯಾವಾಗಲೇ ಒಂದು dioxygen is reacting with the metal, basically it forms their respective oxides. So in all these reactions, what happens, they are directly getting reacted with the oxygen, but there are also certain reactions in which we carry out the oxidation process in the presence of a catalyst. Okay, for example, if I choose as SO2 plus O2, so this reaction takes place in the presence of a catalyst, which is your vanadium pentoxide, to give as your SO3. So when I balance this, I will be getting as a 2SO3 and that of your 2SO2. Similarly, in the case of your 4HCl plus O2, so this takes place in the presence of CuCl2, that is 2Cl2 plus that of your 2H2. So in this reaction, we could just observe that whatever the oxygen is getting reacted with that of your sulfur dioxide and HCl, it is taking in the presence of that of your respective catalyst. So these were the certain important properties of your dioxygen. Coming with respect to their uses. Okay, what are the uses? Of course, we know that dioxygen is very much important for our, what you can say, day-to-day breathing process. But apart from that, remember, your oxygen is used in oxyacetylene welding. Okay, welding process ಅಲ್ಲಿ ಈ oxygen ನಾವು use ಮಾಡ್ತೀವಿ. Similarly, in the manufacture of many metals, okay, metals like particularly in the manufacture of steel, we will be using your dioxygen. And do remember, we have seen in hospitals, even by your trekkers, alva mountain yaar climb ಮಾಡ್ತಾನೆ, even in the high altitude flying, they all require an oxygen tank, of course oxygen cylinders. And coming with respect to the combustion of fuels, whenever your hydrazine, okay, whenever your hydrazine means which one? NH2 bond NH2. Okay, so when it is treated with your liquid oxygen, hydrazine in a liquid oxygen, it provides a tremendous thrust in your rockets. So rocket fuels ಅಲ್ಲಿ ಕೂಡ ನಾವು ಏನದು ಒಂದು ಪ್ರೆಷರ್ ಬೇಕು ಅದು ಫ್ಲೈ ಆಗಕ್ಕೆ. ಓಕೆ, ಆ ಒಂದು ಥ್ರಸ್ಟ್ ನ ಯಾವ್ದು ಉತ್ಪತ್ತಿ ಮಾಡುತ್ತೆ? ನಿಮ್ಮ ಹೈಡ್ರೋಜನ್ in the presence of your liquid oxygen. Okay, so these were some of the important uses of dioxygen. So let's have a quick recap. So basically, when we were talking about the dioxygen, first of all, we saw the laboratory preparation where we have used by heating these salts like your chlorides, nitrates and permanganates. Similarly, through the thermal decomposition of your metal oxides also, we could easily prepare your dioxygen. Then similarly, by the decomposition of your hydrogen peroxide in the presence of your finely divided metals and that of your manganese dioxide also, you can easily prepare your oxygen. Coming with respect to the properties, we saw that your dioxygen is a colorless and an odorless gas. Similarly, there is a three most stable isotopes, that is your O16, O17 and O18. Coming with respect to the bond dissociation enthalpy, it requires a very high bond dissociation enthalpy value because there exists a double bond character. Coming with respect to the reaction part, your dioxygen reacts with almost all metals except few, that is your platinum and gold, and some of the noble gases it is not reacting. So basically, whenever it is reacting with the metal, we have seen that it basically converts those metals to their respective metal oxides. Similarly, when your oxygen reacts with a carbon or a coke, basically it will be giving you that of your carbon dioxide. So these were the reactions where your oxides are directly reacting with the metals. But there are certain reactions in order to make the oxygen to react with certain compounds, we will be utilizing certain important catalysts. That is your SO2 in the presence of O2, that is V2O5, vanadium pentoxide gives you as SO3. Similarly, HCl plus O2 in the presence of your CuCl2 gives you as chlorine gas plus that of your water. Coming with respect to the uses, as I have said, first of all, oxygen is very much useful in our day-to-day life for the breathing process. Apart from that, oxyacetylene, which is used in the welding process. Similarly, the oxygen cylinders, which is used by the hospitals, high altitude flyers, and that of your mountaineers. Similarly, the combustion of fuels in the, what you can say, rocket fuels, we will be using your hydrazine in liquid oxygen because it provides a tremendous thrust in the rockets. So these were the certain important aspects of your dioxygen. Coming to the next part of the compound of oxygen is your simple oxides. So guys, basically when we talk about your simple oxides, do remember your simple oxides are mainly classified as that of your acidic oxides. Okay, acidic oxides. They are classified as that of your basic oxides, and that of your amphoteric oxides. Amphoteric oxides. So when we talk about your acidic oxide, what does it refer to? Yavaga, whenever you are taking an oxide, when it is going to combine with water, if it is giving an acid, okay? In hedutte yavaga ಒಂದು oxide, when it reacts with water, if it is giving an acid, so such oxides are called as an acidic oxides. For example, is your SO2, Cl2O7, CO2, N2O5. So these are the certain acidic oxides example. ಯಾಕೆ ಸರ್ ಇದನ್ನ ನಾವು acidic oxides ಅಂತ ಹೇಳ್ತೀವಿ ಅಂದ್ರೆ, let me give you an example. So when SO2 it is reacting with water, it will be giving you as a H2SO thrice. So whatever the H2SO thrice you have obtained over here, it is an acid. Okay, it is an acid. So our reason in the name, so when certain oxides, when they are reacting with water, if it is giving an acid, so they will be falling under the heading of acidic oxides. So as per the general rule, there is one rule which says that basic agi, it says that non-metal oxides are basic in nature. Non-metal oxides are basic in nature, or in simple words, oxides of non-metal. Okay, oxides of non-metal are basic in nature. Similarly, when you choose your metal oxides, okay, metal oxides, they are acidic in nature. They are acidic in nature. But in this rule, there is a slight exception. Okay, there is a slight exception. What is the slight exception? So whenever you have a metal, mark my words, whenever you have a metals of a high oxidation state, that is, for example, if I choose as Mn2O7, CrO3, V2O5. Of course, your manganese is a metal, chromium is a metal, vanadium is a metal. So according to the rule, of course, they are the metal oxide. They should be what? Acidic in nature. Alva, they should be what? Oh, sorry guys. Non-metal oxides are acidic in nature. Yes. Metal oxides are basic in nature. Sorry. Non-metal oxides are acidic in nature, whereas metal oxides are basic in nature. So as per the rule, what should have happened in manganese, chromium and vanadium? They are all metals. So what should have happened? They should be what? Basic in nature. But when we are studying about their reaction in the water, we are observing that they are providing the respective acids. Chromium is giving you chromic acid. Vanadium is giving you a vanadium acid, and then you'll be getting an acid. So what is the reason? So what is an exception over here is, do remember, whenever your metals have a high oxidation state, whenever your metals are having the high oxidation state, so such metal oxides, to be more particular and peculiar, such metal oxides will not be a basic in nature, they will be acidic in nature. If you just see the oxidation state of these metals, manganese is having a +7, chromium is having +6, vanadium is having +5. So these are the metals in which they are having the high oxidation state. So the metal oxides in which the metals are having the high oxidation state, generally those metal oxides will be acidic in nature. Otherwise, in normal cases, your metal oxides are basic in nature. Okay, coming with respect to now basic oxide. Okay, acidic oxide ಅಂದ್ರೆ ಏನಂತ ಹೇಳ್ತೀವಿ ನಾವು, ಯಾವಾಗ ಒಂದು ಆಕ್ಸೈಡ್ ವಾಟರ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ ಇದು ಆಸಿಡ್ ಕೊಡುತ್ತೆ. ಅದೇ ರೀತಿ whenever an oxide when it reacts with water, if it gives a base, then such type of an oxide is called as what? Basic oxides. Examples, you can just take it as your Na2O, or you can also choose your CaO, or that of your BaO. Why we are choosing this one? If for example, if I choose as calcium oxide, when it is treated with water, it will be giving you as a calcium hydroxide, CaOH twice, which is a base. So that is the reason your CaO falls under the category of your basic oxide. So of course there is another form of an oxide which is going to react both with the acid as well as an alkali. So such type of an oxide which is called as what? Amphoteric oxide. So amphoteric oxides are the one which reacts with both acids as well as an alkali. Reacts with both acid as well as your alkali. Acid and alkali. One common example for amphoteric oxides, okay, it is that of your aluminium trioxide, Al2O3. Very much important reaction, you please pay attention over here. So when your Al2O3 is treated with that of your HCl in the presence of water, Of course, the reaction proceeds to give you a complex, that is an aqua complex of aluminium, that is AlH2O 6 times of 3 plus, along with that one chloride ion. Okay, I just written my ionic reaction. Similarly, the same aluminium oxide reacts with that of your alkali, that is your NaOH, in the presence of water to give you as Na3AlOH 6 times. Okay, so basically you could just see that why Al2 is falling under the Al2O3 is falling under the category of your amphoteric oxides, because they are reacting both with the acid as well as the base. So when you just if you want to just balance the reaction, so first of all, here you'll be having a 6HCl. So here 6HCl means, here of course here 6Cl minus is there. So here comes your 9 water. So if I write here 2, 6 2s are 12. Okay, so the reaction is balanced. 2AlH2O 6 times. Yes, it is balanced. Coming with respect to that of your this second reaction, here it comes as 6NaOH and here it comes as 3H2O to give you as 2Na3AlOH 6 times, which is when we aqueous start. So basically it's an important reaction which is indicating that how does your amphoteric oxides, that is more particularly your Al2O3, is reacting both in the presence of your acid as well as an alkali. The another part, of course, which is your neutral oxides also exist. Neutral oxides, which is not a basic, also it is not an acidic. Okay, neither acidic nor basic. So such oxides are called as a neutral oxides. So one common example, the common examples of neutral oxides are your CO, your nitric oxide, your N2O. So these are the examples of your, what you can say, neutral oxides. So this was the part of your simple oxides, where we came to know that whenever you talk about a simple oxide, it's mainly categorized into 3 important parts: acidic, basic, and that of your amphoteric. Acidic means what we came to know, whenever the oxides, okay, where they are reacting with the water, if it is giving an acid, so thus oxides are called as an acidic oxide. One common example we have seen, that is your SO2. So when it was reacting with water, it has given you as what? H2SO thrice. Similarly, we also saw about your basic oxides. Whenever an oxide reacts with water, if it gives a base, so such oxides are called as a basic oxide. One common example we also saw, that is your calcium oxide, which when reacting with water, it gives you as a calcium hydroxide, which is basic in nature. Of course, from the rule, a general rule which we came to know that generally metal oxides are basic in nature, whereas the non-metal oxides are acidic in nature. But there was a slight exception. What was the exception? So whenever your metals are having the high oxidation state, so such metal oxides will be also acidic in nature. And the common examples we have seen, that is your Mn2O7, CrO3 and V2O5, where the respective metals are in the higher oxidation state. So these are the scenarios which we indicate, that is these metals indicates the respective oxides will be acidic in nature. Then we came to know about amphoteric oxide, which means those oxides which reacts both with the acid as well as the alkali. So there was a common example, that it was your aluminium trioxide, which reacts with both HCl and NaOH to give the respective complexes. That mainly indicates what? Your Al2 reacts both with an acid as well as an alkali. Then we came to know about neutral oxides, which is neither acidic nor basic. The common examples are very much important, that is your calcium monoxide, nitric oxide, and that of your dinitrogen oxide. Is that clear? So basically we have covered so far the 2 important components, or we can say compounds of oxygen. One was your dioxygen and second was your simple oxide. The next part and the last part of this video content, we are going to see another important compound of your oxygen, very much important, because it is only saving us from the skin cancer, that is protecting us from the UV rays. So of course you have come to know that what is the name of that compound? Yes, it is our ozone. Okay, the next important compound we are going to study about your oxygen is that of your ozone. So first of all, we'll have some brief view or a brief knowledge of what about this ozone is. Basically, ozone is an allotrope of oxygen. What we are saying, ozone is an allotrope of an oxygen. Okay, first important point. And do remember, whenever your ozone is present in an atmospheric level, that's that of your oxygen hange ಎಲ್ಲರ ನಮ್ಮ ಸುತ್ತಮುತ್ತ ಇದ್ಬಿಟ್ರೆ, it is highly reactive. It is highly reactive. ಆ ರೀಸನ್ ಇಂದನೇ 3 ಕಾನ್ಸಂಟ್ರೇಷನ್ ನಮ್ಮ ಅಟ್ಮಾಸ್ಫಿಯರ್ ಅಲ್ಲಿ ಅಂದ್ರೆ ನಮ್ಮ ಸುತ್ತಮುತ್ತ ತುಂಬಾನೇ ಕಡಿಮೆ ಇರುತ್ತೆ. ಆದ್ರೆ ಮೇಲ್ ಹೋಗ್ತಾ ಬಂದಂಗೂ ಏನಾಗ್ಬಿಡುತ್ತೆ, ಅದು ರಿಯಾಕ್ಟಿವಿಟಿ ಕಮ್ಮಿ ಆಗುತ್ತೆ. ಸೊ ಅಲ್ಲಿ ಅದು ಸ್ಟೇಬಲ್ ಆಗಿರುತ್ತೆ. ಸೊ ಆ ರೀಸನ್ ಇಂದಾನೆ O3 is highly reactive in the atmosphere at sea level. But when it goes at a height of nearly 20 kilometer, roughly 20 kilometer, what it forms, it is formed from an atmospheric oxygen in the presence of sunlight. So sunlight ಮೂಲಕದಲ್ಲಿ ಏನಾಗುತ್ತೆ, whatever the O2 ಇರುತ್ತೆ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, O2 ಬ್ರೇಕ್ ಆಗುತ್ತೆ. ಆಕ್ಚುಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ O2 in the presence of sunlight ನಿಮಗೆ ಫಸ್ಟ್ ಒಂದು ರಾಡಿಕಲ್ಸ್ ಕೊಟ್ಬಿಡುತ್ತೆ, ನೇಸೆಂಟ್ ಆಕ್ಸಿಜನ್. ಅದೇನ್ ಮಾಡುತ್ತೆ, O2 ಜೊತೆ O ರಿಯಾಕ್ಟ್ ಆಗಿ ನಿಮ್ಗೆ O3 ಕೊಡುತ್ತೆ. ಸೊ ಈ O3 ನಮ್ದು ಏನಾಗಿರುತ್ತೆ, ಅಟ್ಮಾಸ್ಫಿಯರ್ ಅಲ್ಲಿ ಇರೋದು ಓಝೋನ್ ಪಾರ್ಟ್. ಸೊ ಅದು ಯಾವಾಗ ಫಾರ್ಮ್ ಆಗುತ್ತೆ, ಇನ್ ದಿ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಅ ಹೆವಿ ಸನ್ಲೈಟ್. ಓಕೆ, ಆ ರೀಸನ್ ಇಂದಾನೆ ನಮ್ಮ ಅಟ್ಮಾಸ್ಫಿಯರ್ ಗೆ ಒಂದು ಓಝೋನಿನ ಬ್ಲಾಂಕೆಟ್ ಇರೋದು. ಓಕೆ, ಸಿಮಿಲರ್ಲಿ of course we all know, we have studied from the lower class, the main important use of your ozone is what? It is protecting us from the UV radiation. But of course this one also we can easily prepare it. Even the ozone preparation is also possible. So now let us see how can you prepare this ozone. Do remember, ozone is mainly prepared by passing a slow dry stream of oxygen, remember, through silent electric discharge. This silent word is very much important. Silent electric discharge. Okay, only electric discharge ಬೇರೆ, ಸೈಲೆಂಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಡಿಸ್ಚಾರ್ಜ್ ಬೇರೆ. ಯಾಕೆ ನಾವು ಸೈಲೆಂಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಡಿಸ್ಚಾರ್ಜ್ ನ ಯೂಸ್ ಮಾಡ್ತಿದೀವಿ ಅಂತ ಗೊತ್ತಾಗಬೇಕು ಅಂದ್ರೆ ಫಸ್ಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಸಿ ದಿ ರಿಯಾಕ್ಷನ್. ಸೊ ಬೇಸಿಕಲಿ ಏನಾಗುತ್ತೆ, 3O2, ಓಕೆ, ಇಟ್ ಇಸ್ ಗಿವಿಂಗ್ ಯು ಆಸ್ 2O3. ಓಕೆ, ಡೈರೆಕ್ಟ್ ರಿಯಾಕ್ಷನ್, ಸೈಲೆಂಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಡಿಸ್ಚಾರ್ಜ್ ಏನ್ ಮಾಡ್ತಾರೆ, ವಾಟ್ ಎವರ್ ದಿ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಫಾರ್ಮೇಶನ್ ವಿ ಆರ್ ಸೀಯಿಂಗ್ ಓವರ್ ಹಿಯರ್ ಅಟ್ 298 Kelvin, basically it is an endothermic process. It is an endothermic process. ಸೊ ಈ ಒಂದು ಪ್ರೊಸೆಸ್ ಎಂಡೋಥರ್ಮಿಕ್ ಆಗಿದ್ದ ಕಾರಣದಿಂದಾನೆ ಏನ್ ಮಾಡ್ತೀವಿ ನಾವು, ವಿಲ್ ಬಿ ಯೂಸಿಂಗ್ ಯೋರ್ ಸೈಲೆಂಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಡಿಸ್ಚಾರ್ಜ್. Since the process of the conversion of your dioxygen to ozone is an endothermic process, that is plus some x kilojoules per mole. In this case we have x is 142, which you could see in the note part. So that is the reason, since it's an endothermic process, we are using a silent electric discharge. But do remember, a question arises that, sir, why we have to use, in case if you will not use the silent electric discharge, what would happen? The answer is simple. Whatever the ozone you have obtained, it will once again get decomposed. ಏನ್ ಹೇಳುತ್ತೆ, ಓಝೋನ್ ಏನ್ ಫಾರ್ಮ್ ಆಗಿದೆ ಡೈಆಕ್ಸಿಜನ್ ಇಂದ, ಆ ಓಝೋನ್ ಏನಾಗುತ್ತೆ ವಾಪಸ್ಸು ಡಿಕಂಪೋಸ್ ಆಗ್ಬಿಡುತ್ತೆ. ಸೊ ಆ ರೀಸನ್ ಇಂದಾನೆ ಏನ್ ಮಾಡ್ಬೇಕು, ನೀವು ಸೈಲೆಂಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಡಿಸ್ಚಾರ್ಜ್ ನ ಯೂಸ್ ಮಾಡಬೇಕು. ಸೊ ದಿಸ್ ಇಸ್ ಒನ್ ಆಫ್ ದಿ ಮೋರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ರೊಸೆಸ್ ಒನ್ ವಿ ಕ್ಯಾನ್ ಈಸಿಲಿ ಪ್ರಿಪೇರ್ ಯುವರ್ ozone part. Okay, the process is generally whatever the product you have obtained, it is mainly caused as that of your ozonized oxygen. Okay, coming with respect to the properties wise, what are the important properties of your ozone anta kelidre, basically first of all we'll go with its appearance. Remember, whenever we talk about a pure ozone, your pure ozone, basically it is a pale blue gas. It is a pale blue gas. You just see dioxygen was a colorless, whereas an ozone is having a characteristic color of pale blue gas. So in case if you are going to liquefy this ozone, that will be having a dark blue color. Okay, liquefied ozone will be having a dark blue liquid, okay, or a dark blue color. Gas idag enagirutte, pale blue irutte, but when it is in the liquefied form, it will be having a dark blue color. In case if it is a solid, in case you are going to solidify that ozone, it will be having a characteristic color of violet black. Okay, violet black. So this is in the case of its appearance wise. Similarly, your ozone is having a smell, a characteristic smell. And do remember, whenever your ozone concentration is very less in the atmospheric level, it is harmless. But once the concentration increases by 100 ppm, ಎಲ್ಲಾದ್ರೂ ನಮ್ಮ ಸುತ್ತಮುತ್ತ ಓಝೋನಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅಟ್ಮಾಸ್ಫಿಯರ್ ಅಂದ್ರೆ ಬ್ಲಾಂಕೆಟ್ ನ ಬಿಟ್ಟು ಈಗ ನಾವು ಏನ್ ವಾಸ ಮಾಡ್ತೇವಲ್ಲ, ನಮ್ಮ ಸರೌಂಡಿಂಗ್ ಅಲ್ಲಿ ಎಲ್ಲಾದ್ರೂ ಓಝೋನ್ ಬಂದ್ಬಿಡ್ತು 100 ppm ಕಿಂತ ಜಾಸ್ತಿ ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ವಿಲ್ ಬಿ ವೆರಿ ಹಾರ್ಮ್ಫುಲ್. ಇಟ್ ಕ್ಯಾನ್ ಕಾಸ್ ಯು ನಾಸಿಯಾ, ಫೆಟೀಗ್ ಅಥವಾ ಈವನ್ ಅ ಹೆವಿ ಹೆಡ್ ಏಕ್. ಸೊ ಯಾವಾಗ್ಲೇ ಆಗ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ದಿ ಓಝೋನ್ ನಮ್ಮ ಅಟ್ಮಾಸ್ಫಿಯರ್ ಅಲ್ಲಿ ತುಂಬಾನೇ ಕಡಿಮೆ ಇರಬೇಕು. ಔಟ್ಸೈಡ್ ದಿ ಅಟ್ಮಾಸ್ಫಿಯರ್ ಆಸ್ ಅನ್ ಓಝೋನ್ ಲೇಯರ್ ನೋ ಮ್ಯಾಟರ್, ಬಟ್ ಇಟ್ ಈಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದಿ ಹ್ಯೂಮನ್ ಬೀಯಿಂಗ್ ಸರೌಂಡಿಂಗ್ಸ್ ಅಲ್ಲಿ ಉಂಟು ಅಂದಾಗ ತುಂಬಾನೇ ಹಾರ್ಮ್ಫುಲ್ ಅದು. ಸೊ ಆ ರೀಸನ್ ಇಂದನೇ ಓಝೋನ್ ಇಸ್ ನಾಟ್ ಪ್ರಿಫರೇಬಲ್ ಗ್ಯಾಸ್ ಫಾರ್ ದಿ ಸರ್ವೈವಲ್ ಆಫ್ ಹ್ಯೂಮನ್ ಸಿಸ್ಟಮ್ ಅಂತಾನು ಹೇಳ್ತೀವಿ ಕೆಲ ಸರಿ. Whatever it is there, ozone, it is well and good if it is present outside the atmosphere, okay, making as a ozone layer. But once it comes to the inside the system, that is where we are living, very tremendous effect will be there on our health conditions. Do remember. Coming with respect to its ozone's thermodynamical stability, basically ozone is a thermodynamically unstable. ಏನ್ ಹೇಳ್ತದೆ, ಓಝೋನ್ ಇಸ್ ಥರ್ಮೋಡೈನಮಿಕಲಿ ಅನ್ಸ್ಟೇಬಲ್. ಸ್ವಲ್ಪ ಹೀಟ್ ಕೊಟ್ರೆ ಸಾಕು ಏನಾಗ್ಬಿಡುತ್ತೆ, ಈಸಿಯಾಗಿ ಬ್ರೇಕ್ ಆಗ್ಬಿಡುತ್ತೆ. ಅದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳಿವಿ, ಇಸ್ ಥರ್ಮೋಡೈನಮಿಕಲಿ ಅನ್ಸ್ಟೇಬಲ್. ಓಕೆ, basically whenever you're going to give the heat, of course your ozone once again gets decomposed to give you the oxygen, but do remember the process is an exothermic process. ಯಾಕೆ ಡೈಆಕ್ಸಿಜನ್ ಇಂದ ಓಝೋನ್ ಆಗಿದ್ಕೆ ಆ ಪ್ರೊಸೆಸ್ ಏನಿತ್ತು, it was an endothermic. Now when the reaction gets reversed, of course we know that whatever the endothermic will be there, now it will be acting as an exothermic. So even the reaction you correct study madre, whenever your ozone is getting decomposed, it is O3 getting decomposed to O2. Okay, basically what happens, delta H will be a negative part. What you can say with respect to delta S, alva, ಇಲ್ಲಿ ಏನಿತ್ತು O3 ಇತ್ತು, which is a triatomic. So somewhat its movement was restricted ಅಲ್ವಾ, ಸ್ವಲ್ಪ ಫ್ಯಾಟ್ ಆಗಿದ್ದಾಗ ಓಡೋದೇನಾಗಿರುತ್ತೆ, ಕಡಿಮೆ ಓಡ್ತೀವಿ. ಬಟ್ ಹಿಯರ್ ವಾಟ್ ಹ್ಯಾಸ್ ಹ್ಯಾಪನ್, ಇಟ್ ಇಸ್ ಡೈಅಟಾಮಿಕ್. ಸೊ ಸ್ವಲ್ಪ ತಿನ್ನಿದೀವಿ ಅಂದಾಗ ನಮ್ಮ ಮೂವ್ಮೆಂಟ್ ಕೂಡ ಸ್ವಲ್ಪ ಫಾಸ್ಟ್ ಇರುತ್ತೆ. ಸೊ ಡೆಲ್ಟಾ ಎಸ್ ಏನಾಗುತ್ತೆ, ಇಟ್ ವಿಲ್ ಬಿಕಮ್ ಪಾಸಿಟಿವ್. ವಿ ನೋ ದಟ್ ಡೆಲ್ಟಾ ಎಸ್ ಮೀನ್ಸ್ ನಥಿಂಗ್ ಬಟ್ ಇಟ್ಸ್ ಎಂಟ್ರೋಪಿ, ದಟ್ ಇಸ್ ರ್ಯಾಂಡಮ್ನೆಸ್ ಅಲ್ವಾ, ಎಷ್ಟು ಬೇಗ ಅದು ಮೂವ್ ಆಗುತ್ತೆ ಅಂತ. ಸೊ ವೆನ್ ಇಟ್ ವಾಸ್ ಅನ್ O3, ಇಟ್ ವಾಸ್ somewhat fat, so that is the reason movement was less. But once it gets converted to O2, what happens, its movement increases, so delta S is positive. So keeping this one in aspect, what happens to your delta G? Of course it results in a negative value for delta G. So our reason in the net, do remember high concentration of ozone is a very high explosive antanu ನಾವು ಹೇಳ್ತೀವಿ. So it can easily explode out. ಓಕೆ, ಏನಾಗ್ತಾ ಉಂಟು, ಎಲ್ಲಾದ್ರೂ ನಾವು ಒಂದು ವೇಳೆ ಓಝೋನ್ ನ ಯಾವುದೋ ಒಂದು ಕಂಟೈನರ್ ಅಲ್ಲಿ ಸ್ಟೋರ್ ಮಾಡಿ ಅದೆಲ್ಲಾದ್ರೂ ಅದಕ್ಕೆ ಒಂದು ಬೆಂಕಿ ಅಥವಾ ಏನೋ ಒಂದು ಹೀಟ್ ಸಿಸ್ಟಮ್ ತಾಕ್ತು ಅಂತ ಕೂಡ ಏನಾಗ್ಬಿಡುತ್ತೆ, ಟ್ರೆಮೆಂಡಸ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲೋಸಿವ್ ಆಗೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ. ದ ಆನ್ಸರ್ ಇಸ್ ಓವರ್ ಹಿಯರ್. ಏನಾಗುತ್ತೆ, ಡೆಲ್ಟಾ ಎಸ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಡೆಲ್ಟಾ ಹೆಚ್ಚು ನೆಗೆಟಿವ್ ಆಯ್ತು, ಡೆಲ್ಟಾ ಹೆಚ್ಚು ನೆಗೆಟಿವ್ ಆಯ್ತು, ಸಾರಿ ಡೆಲ್ಟಾ ಜಿ ಕೂಡ ನೆಗೆಟಿವ್ ಆಯ್ತು. ಆ ರೀಸನ್ ಇಂದ ಏನಾಗುತ್ತೆ, ರಿಯಾಕ್ಷನ್ ಇಟ್ ಬಿಕಮ್ಸ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ಪ್ರೊಸೆಸ್ ಅಂಡ್ ಈಸಿಲಿ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, ಸಿನ್ಸ್ ಎಂಟ್ರೋಪಿ ಜಾಸ್ತಿ ಅನ್ನೋ ಅರ್ಥ ಏನು, ರ್ಯಾಂಡಮ್ನೆಸ್ ಜಾಸ್ತಿ ಆಯ್ತು. ಏನಾಗುತ್ತೆ, ಆ ಸಿಲಿಂಡರ್ ಒಳಗೆ ಆಕ್ಸಿಜನ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಕೊಲೈಡ್ ಆಗುತ್ತೆ, ಕೊಲೈಡ್ ಆಗಿ ಏನಾಗುತ್ತೆ, ಪ್ರೆಷರ್ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೆ, ಆ ಏನಾಗುತ್ತೆ ಕಂಟೈನರ್ ಇಂದ ಬರ್ಸ್ಟ್ ಔಟ್ ಆಗುತ್ತೆ. ಸೊ ಅಟ್ ದಟ್ ಮೂಮೆಂಟ್ ಅದಕ್ಕೆ ನಾವೇನು ಹೇಳ್ತೀವಿ, ಹೈ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಓಝೋನ್ ಕ್ಯಾನ್ ಈವನ್ ಆಕ್ಟ್ ಆಸ್ ಅನ್ ಎಕ್ಸ್ಪ್ಲೋಸಿವ್. Okay, coming with respect to the another important property, do remember your O3, that is your ozone, it's one of the best oxidizing agent. Okay, it is one of the best oxidizing agent. So where you can see its oxidizing property ಅಂತ ಕೇಳಿದ್ರೆ, basically when you are going to treat your lead sulfide with that of your ozone, it converts, or we can say it oxidizes your lead sulfide to that of your lead sulfate. Okay, lead sulfate. Similarly, your iodide ion in the presence of ozone gets converted to that of your iodine. Okay, iodine. So iodide ion kuda ಏನು ಮಾಡುತ್ತೆ, ಅದು iodine ಗೆ oxidize ಮಾಡುತ್ತೆ. Along with that one, if I just write the whole reaction, 2OH minus plus O2. So these are the common examples which indicates the oxidizing property of your ozone, where it oxidizes your lead sulfide to lead sulfate. Okay, here you'll be having as a 4O3 PbSO4 4O2. Yes. Then here you're having as a 2I minus, since here I2. Similarly, rest all, I think it is balanced, 2OH minus and O2 part. So these are the oxidizing property where you could easily observe that how does it is oxidizing your lead sulfide to lead sulfate and that of your iodide ion to iodine molecule. The next important aspect, of course, in your lower classes we have seen that the main reason for the ozone layer depletion, of course we have seen it is the cutting of trees and all those things. But also one important aspect we'll read, that is by the supersonic jets. Alva ಏನು ಹೇಳ್ತೀವಿ, supersonic jets are also what, one of the most important reason for the ಡಿಪ್ಲೀಷನ್ ಆಫ್ ಯೋರ್ ಓಝೋನ್ ಲೇಯರ್. ಯಾಕೆ ಇದನ್ನ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ಬೇಕು ಅಂದ್ರೆ ಫಸ್ಟ್ ಒಂದು ರಿಯಾಕ್ಷನ್ ನೋಡ್ಬೇಕು ನೀವು. ಏನಾಗುತ್ತೆ, ವೆನ್ ಎವರ್ ಯೋರ್ ನೈಟ್ರಿಕ್ ಆಕ್ಸೈಡ್ ವಾಟ್ ಎವರ್ ಇಸ್ ಪ್ರೆಸೆಂಟ್, ವೆನ್ ಇಟ್ ರಿಯಾಕ್ಟ್ಸ್ ವಿತ್ ದಿ ಓಝೋನ್, ರಿಮೆಂಬರ್ ಇಟ್ ಗಿವ್ಸ್ ಯು ಆಸ್ ಅನ್ NO2 plus O2. And this reaction ಏನುಂಟಲ್ಲ, that is the reaction of nitric oxide and with the ozone, is very reactive. It is very reactive. Now you can ask me a question, sir, you are talking about supersonic jets, then why we require this equation? Why? Because whatever the supersonic jets we are seeing, alva, basically it has an exhaust, okay, where it has to eliminate the smoke and all those things. So our smoke ಅಲ್ಲಿ major composition ಏನಾಗಿರುತ್ತೆ, NO ಆಗಿರುತ್ತೆ. Since it is flying in the outer atmosphere part, okay, ಆ NO ಏನು supersonic jets exhaust ಇಂದ liberate ಆಗ್ತಾ ಉಂಟು, since it is very reactive with the ozone, ಏನಾಗುತ್ತೆ, ಆ NO ಹೋಗಿ ನಮ್ಮ ಓಝೋನ್ ಬ್ಲಾಂಕೆಟ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ಒನ್ಸ್ ಇಟ್ ರಿಯಾಕ್ಟ್ಸ್, ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, ಓಝೋನ್ ಇದಿದು O2 ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ತಾ ಉಂಟು. ಸೊ ಅದು ಕೂಡ ಏನಾಗುತ್ತೆ, ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ದಿ ಓಝೋನ್ ಲೇಯರ್ ಏನಾಗುತ್ತೆ, ಕಡಿಮೆ ಆಗ್ತಾ ಬರುತ್ತೆ. ಸೊ ಆ ರೀಸನ್ ನಾವೇನಂತ ಹೇಳಿದ್ರು, ಸೂಪರ್ಸಾನಿಕ್ ಜೆಟ್ಸ್ ಆರ್ ಆಲ್ಸೋ ದಿ ರೀಸನ್ ಫಾರ್ ದಿ depletion of your ozone layer. So these were some important properties of your ozone. Coming with respect to the uses of ozone, basically the main uses, it can be used as a disinfectant, even your germicide, and for sterilizing water. Water na sterilize ಮಾಡಕ್ಕೆ ಕೆಲಸದಲ್ಲಿ ನಾವು ozone ನ germicide ಅಥವಾ disinfectant ಹಂಗೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. Similarly, it is also used as a it is also used as an oxidizing agent. It is also used as an oxidizing agent for the manufacture of your potassium permanganate, KMnO4. So KMnO4 na use ಮಾಡಕ್ಕೆ we also use your ozone as a better oxidizing agent. Similarly, it is used for bleaching oils, ivory, flour, starch. So main use for sterilizing the water will be using the ozone as that of your disinfectant or a germicide. So these were the certain important uses of your ozone and some of the important compounds of your oxygen. So in our next session, we are going to see the compounds of your sulfur. Okay.